Hello again. Today we are going to connect infinite limits and vertical asymptotes. So let's get started. So we're going to start with an example. We've got f of x equals this rational function here, and we are to write limit statements that correspond to the vertical asymptotes of that function. So first we need to figure out where those vertical asymptotes are. We're going to factor the denominator and make sure that none of those factors also appear in the numerator. So when I do factor the denominator, I get x squared times x minus 2. Neither of those factors appear in the numerator, so they are definitely vertical asymptotes. So there's vertical asymptotes at x equals 0 because that's when x squared would equal 0. And there's a vertical asymptote at x equals 2 because that's when x minus 2 would equal 0. So those are my vertical asymptotes. I need to figure out whether the function is approaching positive infinity or negative infinity on either side of those asymptotes. So to start, I'm going to be focusing on the vertical asymptote at x equals 0, and I'm going to be looking to the left of it. So I'm just going to be plugging an x value that's slightly less than 0 into my function. So when I do that, I'm plugging it into the factored version of that. So when I do that, I get some parts that are positive and some parts that are negative. I'm putting the negative parts in red and the positive parts in blue so that I can easily figure out what the sign of the result is, and I can figure out whether it's approaching positive infinity or negative infinity. So when I plug in negative 0.1, I get a negative value on the top, and I get a positive times a negative in the bottom, which means I get negative in the bottom. Negative over negative is going to be positive, so that function value is going to be greater than 0. That means that the function is on its way to positive infinity as I approach x equals 0 from the left. Now, if I'm looking at approaching x equals 0 from the right, I'm going to plug in something that's a little bit bigger than 0. So in this case, I'll plug in 0.1, keeping track of just the positives and negatives so I know what the sign of the answer is going to be. And so when I plug in 0.1, I get a negative on the top. And again, I get a positive times a negative on the bottom. That means that, again, that function has a positive value. So again, as we approach 0 from the right, the function is also approaching positive infinity. So we kind of see what that looks like. Now I'm going to focus my attention on x equals 2, again, plugging in a number that's a little bit less, like 1.9. If I plug that into the function, I get a positive value on the top, and I get a positive times a negative on the bottom. So overall, I get a negative value for that function, which means as I approach 2 from the left, the function itself is approaching negative infinity. Then if I plug in a number that's a little bit bigger than 2, like 2.1, I get positives all over the place. So the function value is going to be positive, which means that as I approach 2 from the right, the function is approaching positive infinity. So those are the limit statements that correspond to those vertical asymptotes. All right, so a different kind of example. Let's say that f of x has a parameter b in it, and I'm actually told that as x approaches 5 from the right, the function value or the function values approach negative infinity. And I need to know what value of b is going to make that happen. Well, obviously, there is some kind of a vertical asymptote at x equals 5. Otherwise, it wouldn't really go to negative infinity. So that means that the denominator is going to equal 0 when x equals 5. So that means when I plug in 5, I should get 0. So x squared minus b squared becomes 5 squared minus b squared. Set that equal to 0, and that means that b would have to equal 5 or b would have to equal negative 5. It's one or the other. It could be both. I don't know, but I have to try. So if b is equal to positive 5, I'm going to look at numbers that are a little bit bigger than 5 because remember, I'm approaching 5 from the right. So if I plug in 5.1, I get something that is greater than 0, which means that the function would approach positive infinity, and that's not what I want. So b can't equal positive 5. My only hope is negative 5. If I do that and I plug in 5.1 as my x, making b negative 5, then I get a negative over a positive, and that's going to be less than 0. That's going to be negative, which means that as I approach x equals 5 from the right, my function value will indeed approach negative infinity. So that means that the value of b would have to be negative 5. So that's today's lesson. If you have any questions for me, please let me know, and I will see you tomorrow.